Hi everyone, it's super nice to be here. Thank you for staying back for so long for this last talk. I'm very grateful for your presence here. I'm not going to spend too much time on my background. That's in the session description. I want to get to know you guys a little bit though. Just want to understand the distribution of the kinds of people who are in this room. How many people from actual education institutions, K-12, schools, higher ed, excellent. I really did not expect that at this conference, but I'm really glad that's the case. Developers, engineers, technical folk? Okay, so that's the majority of you. You guys will be the people I'll disappoint the most. And organizational leaders, process leaders, program managers? Okay, excellent. This is awesome. I'm not going to be doing a very technical talk since this does fall under the AI Business Summit. All right, let's get started. Okay, so I do fear sounding a little meta and repetitive, but it's important to step back and look at what AI actually is. You know, we all know that it's a field dedicated to making machines kind of emulate the cognitive functions that humans do. But that sounds pretty general and viscerally omnipresent, right? Search is very AI, and so is databases. We put information in, and then we can query them easily. Perhaps any feed, any software or application where you have feeds which show you something very personalized, or the hotline numbers you guys use whenever you want to call AT&T and they make you go through that maze. And I call this idea the AI presence paradox because AI has been around for the longest time. We've just not been calling it AI. And for very long, we've been resisting this phrase. So the reason it's important to have a conversation about this is once we come to the realization that we're on the other side of it, we can work towards kind of improving it or moving in the right direction as opposed to saying AI is going to kind of replace our teachers with robots. And I think that's the rhetoric that's hurting the education industry the most when it comes to adding technology or supporting it with AI. It's also really important in education for the simple reason that teachers, so schools are most affected by this human capital constraint, where you have well understood tasks of how to teach, but there's a severe limitation or constraint on these systems. So, and whenever you come up with this scenario where you have tasks that are understood and you have professionals or experts who do it really well, but you can't get enough people to do it, that's where you have AI can position itself pretty well to solve those problems for you. Now, if AI has been around for so long, if I talk about these things like databases and search as AI, why have we only recently started throwing conferences at it, right? And I think the most important thing to realize is it's because we've made some massive strides in machine learning, primarily supervised machine learning, to the point that everyone thinks that, or many people think that AI is equal to supervised machine learning. Now, for the unacquainted in the room, machine learning is basically a science where a computer goes on to try to determine some kind of prediction, make a prediction, come up with an approximation function, and it's very statistical in nature. So example, I take my phone, I point it in the sky, and I say, hey phone, can you tell me what the weather is like today? What do you think is going to happen? The phone's going to be like, hey, I don't know, what the hell are you asking me to do? But it turns out that even humans suck at this task, right? You take a 3-year-old or a 4-year-old who's not fully acquainted with the idea of centigrade or Fahrenheit and ask them to look at the sky and say, hey, kiddo, what's the weather like? They're going to be as confused. But if they see the weather, they see the sky for long enough and you tell them, okay, for this particular sky, this is what the weather is like, over time they kind of get these data points in their head and they're able to make predictions. That's essentially what machine learning is, and what makes it supervised is having the data. So when you make the kid look at the sky and say, hey, today is 102 degrees Fahrenheit, so they have that picture in their mind, they have the labeling association with what it is, and that's what makes it supervised once they've seen enough examples. Another really important idea to understand about AI is that it's not a discipline limited to math and computer science at all. It famously has roots in psychology, in sociology, in linguistics, in neuroscience, and when we're talking about psychology, we're primarily talking about childhood development. So we're kind of tainted in our view of what AI is because of what the job market and recent kind of advancements makes us feel like. And these are all the things that AI could be. But why do I care about pointing out these very generic things about AI and I talk about teaching and learning? And the very simple reason is that if you've been in schools, if you've been around teachers, if you've kind of worked with superintendents or school leaders, you'll consistently see learning scientists and educators actually do a lot of work in AI without attributing it as AI per se. A textbook example is, and this happens for the few people who raised their hands when asked who's working in a school or higher ed setting, you'll consistently see this model where you kind of map learning outcomes for a bunch of skills that students have to master over a certain period of time for competency in a certain area. You put them in a database. Eventually, you use this database to make decisions. You possibly, in the future, will be giving this database of skills and competencies to machines to infer what they are and provide supporting content. And this is a classic example of AI. It's a problem of knowledge representation. How many of you know about what Common Core is? I see the same hands, some of the same hands who were in the education space. So Common Core is one of the most textbook examples, pun intended, of use of AI in representing what students need to learn, because we are trying to model what might be a natural progression of learning in students' minds. So once we talk about AI in this sense, or once we start saying, well, this is AI, this was always AI, and AI is very valid in the educational domain as much as it's in healthcare or it is in kind of home-assisted voice devices, we get exposed to this gush of literature which has been accumulating for 10 or 20 years now, which is suddenly really applicable to us in the problems that we're trying to solve. And I'll try to point out some of these, and it'll naturally start making sense to you guys. So, we've been doing work in AI in education, and this is a reality that a lot of people actually don't know or feel comfortable talking about. And one of the reasons is, even though we've been doing this work in AI, we've not been really inclusive, right? So for every one teacher who understands that AI needs to be the supporting element to the teacher in the classroom, there are 5 really clueless idiots who say robots are going to replace teachers. And it's because of those 5 people to that one person who's doing good work that we get this really bad rap for what AI could be. Now, what are the people who are actually doing work in AI doing though, right? They're mostly doing scientific research to make the learning process better and better. So either they're advancing learning theory, so you could purely be working on learning science, which would still be an AI discipline, or be trying to borrow ideas from machine learning and put it in the context of classrooms and learning, and that's the work they've been doing. Now this is interesting because it does a good job at kind of meeting the needs of the learning goals that people have started off with in those communities, but it doesn't necessarily take in the educational climate into the context. And that's completely fine. One would argue that there's pros and cons to each approach. Science should not be kind of hindered by the constraints of some difficult or complex human factors. There are others who would argue otherwise. But what they've been primarily focusing on is this idea of cognitive mastery systems. Now, cognitive mastery systems, it's just a big buzzword, complex word to say, doing a lot of tasks that help you become proficient mentally at something. We're not talking physically, so we're basically saying, you guys probably have some of those apps in which, it makes you do a bunch of tasks and then makes your memory better, makes your transfer skills better. That's essentially what cognitive mastery systems are. In education, we've been focusing specifically on intelligent tutoring systems. Now, these are a particular breed of cognitive mastery systems, but they're focused on kind of mastery of subject material, such that as you keep advancing through material, it keeps making predictions on what's the next best thing to throw at you. If it figures out that you're not doing well on certain things, it knows that it has to give more remedial tasks. So this is kind of the intelligent form of tutoring systems. This is not the same as a teacher putting on an online quiz and sending a link to the students, which is kind of preset. Remember, because I said initially that it becomes AI when it's personalized or when it's adaptive in nature. The other thing we've been looking at or doing a lot is intelligent testing tools. So say you have a tool from ACT or Kaplan and you're writing essays for SAT. And at the end of writing your essay, it basically tells you, hey, your use of grammar in certain places wasn't good, or you didn't build the argument right. So this isn't necessarily taking you through a bunch of activities or exercises to become good at writing it, but it gives you feedback. It's intelligent too. As I mentioned, this is not happening in kind of true educational climates, or trying to understand the complexities that schools or school districts. I've worked a lot with administration of schools, and I understand the disconnect between these pure scientific perfect solutions and the constraints of hardware deployments, the constraints of teacher professional development, the constraints of going beyond that one pilot. You'll have a lot of companies and solutions come out and make a perfect solution for 2 units or 1 course. Beyond that, it's absolutely useless. And so one of the approaches that has been adopted recently in the industry is this idea called design-based implementation research. This is not a solution, this is a technique. And the technique here is, it's a research technique which is saying, when we start off our practice, when we start off with a research question and hypothesis, instead of doing it independently in the lab of University of Washington or University of Colorado, we're going to work with a school district or teachers, and they're going to co-design this experiment with us. And that somewhat introduces real-world constraints, although still it is very, very tricky to go from one classroom where you've worked with a teacher for that perfect math unit into something that can work even in the next state. And the educators in the room kind of understand this complexity all too well. Now, if we think the things we're doing are good enough, the question we want to ask is, how the hell are we doing on these things, right? This has been the focus of the kind of scientific learning science community or AI community in education for the past 20 years. So begs the question, how are we doing? My personal opinion is we're making progress. We're making decent progress, but very humble progress. There's a decent foundation laid here. But we're far slower than the pace at which AI research and productization in companies are happening today. Why that's important is because if we want to really kind of use or make the best of what is being produced by research in these companies, we've got to really expedite our pace. You guys understand this idea of AI winters. In the past, we've had times or phases where AI research, AI applications have been really non-existent. There's been very less research. There's been kind of disappointment all around. Successes haven't come through. We're not in that, right? We're in an AI summer. So this is a good time to kind of rethink how aggressively we should be acting on AI and education problems. So one of the important concepts that comes up is when I talk about intelligent tutoring systems, we're talking about intelligence that starts with this assumption that students and teachers have laptops and devices in their classroom, and making it feel like, okay, if you get the laptop and tablet in their hands, oh, their life's going to change. We're going to make some amazing adaptive learning solutions. This isn't true. I've been in this space for 15 years now. 15 years ago, the point that people made was computer penetration's too bad. Laptops are non-existent. They're too expensive. Make them cheap. Then we'll make great adaptive learning experiences. 7 years ago, we got smarter at arguing about this. We said, no. Our new excuse is the total cost of ownership is too high. The adaptive learning solutions never came. And today we're coming up with more excuses, but the cost of the devices is not a problem. We've for some reason constantly masked our failure to do good work in adaptive learning by saying the cost of the device is the problem. We've just not made magical successes in adaptive learning. Cell phones are dirt cheap. I'm not talking about rural classrooms in Ghana. Because it's very easy to take those examples and say, we can get computing here, we can get Wi-Fi here. Every kid in a private university in the US is carrying at least one computing device on them to the classroom, and we've seen practically no intelligent kind of learning or tutoring experiences. I point out that solution because it's the one place you would imagine something comes in, because people are paying 40 to 50K for 1 year of education. So you don't have to go to Africa to make these arguments. Now, some people say it's a chicken and egg limbo. Researchers and entrepreneurs say, we've been trying really hard. Schools don't want to adapt our solutions. You go to any accelerator where education companies are being funded, and out of 12, 10 are basically doing adaptive learning. They're saying, we don't have an audience for this at all. Nobody's taking our products. You go to any teacher and ask them about for the 5 or 6 products they've tried at EdSurge Summit, and they're probably all going to say they're garbage. They absolutely don't scale. We tried them. They worked great in the demo. Those 5 example questions they showed us were wonderful. but boy, they just completely crash when we go take it into the classroom. So this is understandable. I was an entrepreneur. I feel this pain. So I think my general takeaway from this is that if we continue to take a limited view of intelligence in the classroom, of we've got to have this screen in front of the students, we're going to make it difficult to bring these intelligent experiences, because the chicken and egg problem will continue. But the other larger problem is that to allow adaptive learning to scale, you're expecting a paradigm shift where educators understand and parents understand and the community gathers together to say, hey, the computer is the master, the teachers are just on the sidelines. I think this can happen possibly if the adaptive learning solutions are so good that the teacher is just not able to keep up with it or do as well. But that value prop is really high. I don't even think we'll get there in the next decade. So I call for a very different approach to look at this problem, which is a low resistance problem and a high value problem, which is dependent on some of the successes we've made in AI in the past 10, 20 years. And that is to use our knowledge and successes in perception, in vision and speech. So if you've been attending a lot of conversations around AI, more often than not, they're going to be talking about what we can do with image captioning, recognition, object detection, and they're going to be talking about smart speakers and the conversations you can have with these devices. I really think that there's a perfect opportunity here to take away the learnings that we've had in those domains and actually treat the classroom as physical, teacher-supported environments and use the input data points that students are producing. Students are always acting, they're always producing sound, they're giving the right signals and messages. I treat the role of AI to be different. I think it's much better when we have AI that's capturing these signals and then using some sort of mechanism to determine what's going on in the classroom and then passing pedagogical and curricular guidance to the teacher. But the teacher still is the person who's conducting the lesson rather than kind of handing it off to the computer. And Rose Lukin, I may have gotten that wrong. She's one of the leading researchers in the spaces, and she calls us the AI as a TA kind of framework or way of thinking. And I think this perfectly aligns with what I've always thought about. This will allow us to kind of work on bringing AI into classrooms a whole lot easier, because you've shifted from this conversation of putting devices in front of every student to saying, and more importantly, to changing the role of the teacher, to saying the role of the teacher stays. We just augment their ability. This is also not a perspective that I uniquely kind of champion. This is now recently a conversation that people have begun to have. And so we'll see more of this. Now, I've identified like 7 key areas where AI is going to be important and critical for coming in teaching and learning. Remember, I'm not talking about education in general. I'm not talking about equity. I'm not talking about policy. I'm not talking about access. I'm talking about teaching and learning specifically. This will all be published in a completely free and open handbook very soon, so you don't have to take notes right now. But I'm going to be focusing on 3 of them, which I think are uniquely important and interesting. And they're all based on this teacher as an AI framework that I've just laid out. I'm also going to be talking at a very high-level overview. I'm not going to be going in any technical depth of trying to explain how a certain model works or how a certain tweak of a hyperparameter is going to change things, because this is part of the AI Business Summit. And because this is a thing that we don't think about every day, I'm just basically laying a framework for a conversation so that when you go back to your schools, your classrooms, in organizations where you have learning as a critical priority, you have a structure to talk about these problems. And then you can very easily lean on the research and kind of make investments where you think they're valuable. All right. So let's start off with, I think, the most interesting one, which is feedback and scoring. The reason I think it is interesting is because most of the problems in feedback and scoring represent the entire spectrum of AI. We start off with something really shallow, like asking students a question of, how are you feeling good today? Are you feeling bad today? And they say good or bad. So this is like an if-else. This is a conditional. This is the bare minimum you should do in a system to call it AI. We're putting a condition forward, and we're saying, okay, what do students feel? I can segment the class by how many people are feeling good, how many people are feeling bad. This is your shallow feedback. And then there's AI completeness. Okay, this is a complex concept. Won't get into it too much, but to be AI complete is basically saying we've solved pretty much most of the important problems of AI such that it starts, we can build generalizable systems. For those of you who got it, good. For those of you who didn't, I will talk to you after the session because this takes time to explain sometimes. Let's talk about the problem space. So for each of these three problems that I'm going to be talking about, I'm going to be introducing the problem space, and I'm going to be talking about the opportunity space. I'm not calling it a solution, because then I become the technophobe who talks about solutions to complex education problems. I don't want to be that guy. So it's really critical to human learning. We all know how critical feedback is. We've all been in a classroom at some point or the other. I actually really hope you guys have been. This is... It's really essential to high stakes and low stakes assessment. So whether you're talking about, your examinations at the end of the year, or you're talking about, a diagnostic assessment, formative assessment. How many of you know what formative assessment is? Okay, this was a very meta question because that is exactly formative assessment. I'm in the middle of teaching you something and I'm asking you what formative assessment is. So it's basically having these quick checks for understandings within the context of any learning session. And I think the other thing we realize, how many of you know a teacher in your life, like mother, family, like aunt? Right. So you guys realize that they're really bogged down by grading, and they hate it because it's really, really time consuming, and it keeps them away from what they do best, which is solving problems for students. We're talking about teachers completely bogged down by grading, spending a huge amount of time, check marks and red ink, but students are still complaining about not enough feedback. I think I remember my teachers in high school spending most of the time grading. They barely showed up to class, but we still complained. We did not get enough feedback. I think this is the reality even today. Nothing's changed, so the gap is huge. And what happens when you can't get enough feedback and you can't have a clear loop? Teachers resort to lecturing. When a teacher does not know exactly where students are at any given time, what do? They go back to the textbook and they say, let's just go with the lecture because I really don't know where to focus. But the best teachers in this country, in the world, they know exactly where their students are at all given times, and they're able to target specific instruction, specific group activity around that. Now, what does the feedback process look like? This is not rocket science. You throw a question, you get some answer, you perceive the answer. You get someone says a long sentence. For a moment, you try to figure out what did they just say. You try to understand it because students speak like students, and you can't get it the first time. And then you compare it with the expected response. Every time you throw a question, you've already framed a kind of perfect or ideal response in your head. If it's a complex question, if this is in the context of a kind of a written exam and someone's written 2 paragraphs on it, it's got a lot of variables, as a machine learning scientist would say. So you have to kind of extract, okay, this part of it is right, good use of this factual concept. I think the argument does not hold though. So you're using a rubric to say, okay, they've got 2 of these 4 things right. Our criteria says let's just give them 50% or let's give them 60% because these 2 were more important than the other 2. And then you use the delta from the comparison between, what was your perfect response and what the students gave to construct feedback. Teachers do this magically fast. They do this 100 times a day. What's interesting is if we're talking about AI, we should also reference what Andrew Ng says, which is if any task can be done within less than 1 second, then it's kind of ideal or ripe for AI to kind of solve. But in the case of a science lab experiment, teachers are not just doing this task once. They're doing this task 6, 7 times because for every question they ask students, for every stimulus they put out there, they get a different response. Students kind of respond to gathering the materials differently. In the next step, they're supposed to, fill that chemical solution in the beaker. So there's a large amount of response and stimulus going on, and that's why it's cognitively complex. No teacher is complaining about the fact that they can't respond to multiple choice questions, which your great Scantron solutions, which is A, B, C, D, which one is colored, machine learning, great, figure it out. That's not a problem for teachers. The problem is trying to figure out what the depth of understanding is, because depth of understanding comes from questions that are slightly more complex than a one-word response or, check this one box. So the problem space looks like this. We're throwing out a kind of question out there. Then we're kind of seeking input. Students respond in text, oral, drawing, affective states. Affective states are basically emotional record, like emotions, which they show on their face. Gestures, computer inputted in case they're using fancy Google Docs or Google Forms. And understanding it is basically, so say, I have a sentence. I've asked for a one sentence answer. You get the one sentence answer. It takes a while for me to figure out what pieces of it are in the answer, and then classifying them to say, okay, this is clearly worthy of 8 out of 10. This is clearly not good enough. Let's give this a 4. And then for complex response types that I talked about, essays or longer response types, you have a rubric which helps them grade. It's not enough to tell students that they have not met with the expectation of the rubric. A lot of teachers actually do this. They just say, we gave you the rubric, you screwed up. What's really important is that you give them the supporting resources and you tell them, here's the mistake you made, and this is the exact intervention or activity or practice that you need to go through to correct it. Okay, that was the problem. This was a little stating the obvious. You guys are, we've been in schools, we've experienced this. What are the solutions here? We'll come back to structuring queries because machine learning or AI gives us plenty of opportunities in trying to construct questions. But let's start off with seeking inputs. Again, there's not much you can do with AI in asking people to give you inputs better. Yes, you can distribute questions more reasonably. But really not much opportunity there. The real advantages or opportunities come in perception. Students are mostly responding in handwriting today. If we remove the segment of classrooms, the Bay Area classrooms with amazing iPads on everyone's desks, they're still writing. And one of the areas where we've made massive strides is in understanding handwriting. Famously, whenever you try to learn machine learning, the first example they'll give you is how to understand handwriting. This is through a technique in deep learning or deep neural networks called convolutional neural networks. The recent successes or recent kind of breakthroughs on top of that have involved something called LSTMs. Don't worry about that. They all get us a higher accuracy than the tools you used when you were a teenager, which barely interpreted your perfect printed documents well. These systems start off with drawing boxes and figuring out what the word is, then using something called language models, which are just glorified multi-dimensional dictionaries that help you understand what these words meant, and then put them together. And you're thinking, well, so what does that mean? We have a student, every time they respond to a question in the classroom, they go to a scanner and they kind of scan their sheet and we run machine learning on them. No, what I'm talking about actually using advances in computer vision to help us take pictures from multiple angles and then use this idea called perspective distortion, which allows us to say, even though the photo was taken from this angle, we can actually make it look like it was a perfect scan, and then run these handwriting recognition algorithms on. Again, we're talking about perception. We're still not talking about understanding what it says. In speech, we have made massive progress in what we call automated speech recognition. Using this idea called recurrent neural networks, also an idea in deep learning. Don't worry about it if you've never heard of it or you don't want to go into it. We take audio as spectrograms or MFCCs. These are representations of audio, feed it into neural networks, which kind of give us the exact text of the audio. And we've also been able to solve some fringe problems, which is, if we have an audio clip with 10 people speaking, can we figure out who's Melanie? Can we figure out who's Matthew? Can we distinguish the speakers in the setting? And also in far field, I'm guessing most of you have Amazon Alexa or Google Home at home? Yes? Okay. So it's this very same success in, understanding what when you say, hey, Alexa, please don't turn off. Okay. To understand what students are saying, except, in a classroom, it's a noisy environment and you're trying to capture multiple signals. So we have research that has been trying to solve some of these problems. And also actions, sorry. Oops. Right, actions, gesture recognition has given us enormous successes. I'm running out of time, so I'm just going to go a little fast. Understanding input is also pretty important. Once we have this as text, there's an entirely massive space called natural language understanding, which helps us extract kind of the parts of the speech using lexical understanding of sentences. We use some statistics to understand its structure, its entities. And then in the educational domain, there's something called knowledge components or schemas, which help us understand the web of relationships between concepts and topics. So once we perceive what the student has written for us, we can actually understand what are the topics, what are the entities, what are the ideas, what are the nouns or phrases they're talking about, and the relationships between them. We can construct responses or feedback or support with it using this idea called natural language generation. The general idea I want you guys to remember out of this is we're good at doing these things individually. We have some great successes. We have some good accuracy. Accuracy is the way AI scientists measure how good our AI is. But these have not been, they've worked in these isolated scenarios. We're not great at doing them in sequences. So when I talked about sequences, I was talking about the science lab experiments, right? Bunch of feedback loops all in one single setting. And we're also bad at doing it in generalized settings. So we've figured out how to make this work in the laboratory, not so much in just any classroom in the country. I'm going to skip through this section on learning challenges, although it's very close to my heart. And I think special ed is a place where AI can be massively useful. But I really hope at some point in the future, somebody can talk about this. There's enormous opportunities in these two areas that I call hoping to understand and hoping to be understood from the perspective of a person who's differently abled. We get a lot of abilities from the perceptive capabilities that we've produced with AI in understanding from the multiple dimensions of inputs that come to a person, how they can perceive it, go through it at the pace that they're comfortable with, or lower the intensity or dimension at which they consume it. And these are too complex to, again, talk about in this session. And then there's the aspect of hoping to be understood, which is they often cannot, again, I'm fear generalizing here, but some categories of people with learning and physical disabilities cannot express themselves just the way all of us do. And so we have opportunities for generative modeling, which allow us a bunch of techniques, a bunch of subfields, which allow us to produce sound, to produce text as expressions, as responses to people, without them having to generate the same amount of energy or use the same number of muscles in their face to get the same reaction, because machines can just do this stuff well. The problem space that I find very fascinating, and I'll just go through it in 5 minutes, is curriculum development and alignment. This is the thing that most people will complain the most about because it's a very, very difficult problem. Curriculum doesn't work for most students today. And I'm not saying personalize it or throw, it doesn't have to be digital. But the clear evidence for this is that, when curriculum works, students are mostly engaged at all times. There would be no times when students feel lost or confused. So think about that perfect lecture in high school or college where you were just up with it the whole time. That's what good curriculum and instruction looks like. And then everyone reaches the expectations at their age level or grade level equitably, unlike the kind of bell distributions that we end up in naturally. This is a seriously non-trivial problem. And the reason you know it is you don't have to ask machine learning scientists why this is non-trivial. Most teachers I know still sweat at the thought of constructing curriculum themselves. and creating coherent lesson plans, coherent units, although it's assumed that most of this has been a solved problem and teachers know it. But in reality, it's a big struggle. And this is teachers who have been teaching for multiple decades. When I was in the classroom, I struggled with it. My mom's been teaching for 30 years. She still freaks out. So what teachers resort to is kind of reading the textbook or following the pace of the textbook, which is in no ways what students are ready for or adapts to their existing need. So these are the 8 spaces. So what happens is it's a non-linear process, and that's what makes it extremely, extremely difficult. You've got to know where your students are at all time, in the middle of a lesson, in the middle of a unit. You've got to understand competency expectations. So your state is throwing some expectations, your vice principal is throwing some expectations, and you have to constantly in your mind keep making predictions of pacing. Okay, so if I take 2 days for teaching this here, just by giving that extra activity to boost their fluency, what will happen to the rest of my unit? Will I run over time? You've got to know pedagogical content knowledge, which is a fancy way of saying the best instructional activities, the best ways to teach a particular piece of content. Got to know how learning will be assessed. Got to understand what your examinations will finally look like. You got to understand how your students are feeling at all times. In the day, during the week, in the semester. You got to understand how to construct materials. Again, a very labor-intensive, complex process, which most people just wing and get away with for most part. Got to understand practical resource limitations. Teachers are working at all times with a very, very clear financial limitation in front of them, so they cannot just do everything that's magically possible. They can't just go to National Geographic and buy, $2,000 assets because it's going to bring the classroom to life. It's just not practical. And knowing the content. All right. I'm seriously going to rush through this. I got 2 minutes, and I'm going to skip stuff that's not important. So in AI in education, one of the spaces where they have made the most progress is knowing where your students are at all times through this technique called knowledge tracing, either Bayesian knowledge tracing or deep knowledge tracing. Well, it's a very simple idea. It's basically saying, I'm going to ask you a bunch of questions that are completely isolated with each other, and I'm just going to keep track and build a statistical understanding of how much you have mastered things. This is actually, funnily, that simple approach is the most common way of intelligent tutoring systems trying to figure out how much students have mastered things. And I think the most basic elemental unit of that is one knowledge component. And they just treat things as different. 100 skills, no overlap, no complex understanding of them. All right, competency expectations. Again, we've talked about natural language understanding. So you take a very complex statement of what someone needs to master. Think about your classic student will be able to, and then you have a complex statement. You can have a computer interpret or understand that. This is often tricky for most teachers. If you show them some of the more trickier parts of a standards document that the state has put out, or Common Core state standards, even a teacher who's been in the industry struggles to interpret, what does this really mean? What does this really entail? So this is also a very learnable problem. Then there's pedagogical content knowledge. This is a learnable problem. So what do I mean by a learnable problem? A learnable problem is basically, if I give students enough practice through a certain technique, I can learn over time if that's working or not. And so I talked about that example of taking a photo in the sky and trying to figure out if, what the weather is like. So this is also a very learnable problem. Knowing how learning will be assessed. I'm going to jump over this one. It's going to take time. Knowing how students are feeling. We've talked about affect recognition and trying to interpret emotions of students in the classroom at any given time. And if machines can do that at a significantly smarter pace than teachers can, you don't have to scan 40 or 20 faces every day to try to figure out at all times, to constantly try to figure out how students are feeling. Are they anxious? Are they tired? And the machine can do that for you. It's just much, much more easier for you to focus on the things you care about. Knowing how to construct materials, we talked about the idea that, in feedback and scoring, you can construct sentences, you can construct audio. This is the very same idea. Nothing AI can do about low budgets. Please, government, solve that problem. And knowing the content is, over time, AI is getting smarter at reading long texts, textbooks, articles, and trying to understand the meat of the discipline. Today, it understands sentences in isolation. It understands simple concepts. You give it a definition, it can probably build an understanding. But to build an understanding of a complex text of isolated components is very difficult. So where do we go from here? You're like, cool story, dude. Abstract pointers, you've not really left us with some great ideas we can implement. And I haven't, and I admit that, because there are still some problems to be solved. There are three big challenges in front of us. We still have very limited data. Unfortunately, for most problems that can be solved with machine learning, most of the solutions I gave you, data is a critical piece. We've not reached near perfect accuracy on many of these problems, especially when I said they're sequenced and they're in a more comprehensive, holistic manner. And I think the biggest thing I complain about all the time, which is we don't have domain-specific or industry research. We cannot ask Microsoft or Amazon Alexa to try to figure out how to make understanding of student speech in classrooms good. My core suggestion, how many of you know what OpenAI is? Okay. So if you know people with deep pockets, we need something like OpenAI, but for education. These are massive infrastructural pieces. These cannot be built by any one nonprofit or for-profit. Gates Foundation tried to make a data effort through 100 million at it a few years ago, magnanimously failed for different reasons. But we need independent nonprofits to build this AI infrastructure so that every school, every startup, every researcher, all of you can use this. This is not rocket science stuff. It's very possible. That's my Twitter ID. Please feel free to write to me. Thank you so much for your attention. I really appreciate it. I think I'm officially not allowed to ask for questions because we run out of time, but there's no session after this. So I'm around, the mic's here. I welcome it. Yes. Okay. We have a mic question. So whoever.
Question. So I have one question, and it's fascinating. I work in the business of trying to do all of what you're talking about. The issue that we have is privacy. And when you think about having a connected classroom and you're taking in all this private conversations that kids think are private, but they're not really, and we're parsing it and using it. Just even trying to get test data from state departments or districts is a tough lift, even when it's anonymized. So how do you perceive getting around that issue?
Yeah. So I'm really grateful you asked that question. I've dedicated an entire section to it in the handbook. Not that I'm advertising it, because it's free anyways. So in recent years, Anirudh is actually a person who has done a lot of work on this, who understands this really well. We have always thought of machine learning to make inferences, decisions, predictions, as I talked about, in the cloud. Some remote server where we pass data or information. That has been the precedence for the longest time. But in very recent years, we've been actually moving away from that model or thinking about a much more advanced model where we are making predictions or inferences on the edge, as they say. So my solution to this, I don't know if it's a perfect solution. I don't know if there is a perfect solution. But I think if we have built an understanding from anonymized data that has been well cleared once or twice, then we can move these models to the edge where within the classroom, that data is never leaving the confines of the classroom. You make those predictions and inferences, and you keep improving it from what's the anonymized stuff which was collected separately. And I think you just don't have to send data to the cloud. There will be no single institution with all the data. You have your SIS systems. They talk to a machine right in your room, and nobody else touches or talks to it. Yes, that I don't have a good answer for. I think so. When I actually explain what we should do with or solve the data problem, a lot of the newer techniques in the past 3 or 4 years have revolved around sample efficiency. How can we make models that work with or are trained with much smaller amounts of data? We have some successes in reinforcement learning that are promising, but we haven't made massive breakthroughs there. But I think it'll be a combination of the two, on-edge computing and inference, and sample-efficient training. That makes sense. One more question.
Yeah, so it seems like there's a lot of scope in this field. So I'm just curious, can you name some researchers or companies or some people that you feel you can follow, just who are making some sort of strides in this field, or who have visionary ideas that we can follow or that might inspire us?
Yeah, yeah. There's a lot of people. I would say a good starting point is there is a particular learning community that this year they had something called the London Festival of Learning. Just look up that phrase, because there were 3 different conferences around AI in learning. One was called Learning at Scale, one was called AI in Education, and the third one, I forget the exact name. So there, all the work that I'm actually referencing, you will understand the current state of literature there. Now there's a lot of companies who are also doing, almost every edtech company or education company today is doing some form of AI. You go to ETS, you go to ACT, you go to Kaplan, they all have AI departments. But I would start off with the literature, because I think companies are actually behind in this case. Cool. Thank you so much for coming.